Hey, this is Miss Weatherell. I'm giving you a mini lesson on rotational symmetry. It is not a very hard concept to learn, so hopefully you can pick up on it really quick. One moment. There we go. So we can get there. There we go. I was getting my slide presentation working. All right, so this is rotational symmetry. Basically what rotational symmetry is if you are taking an object or a figure and you are moving it in a circle. So you're moving it in a 360-degree area. And you're trying to figure out if you can rotate this circle any times or how many times you can rotate it, if any, and it would look exactly the same. So if you're watching this, watch that H. So I rotated that one time, and then I would rotate it one more time to get back to my original figure. So we say that this has a rotational symmetry order of 2, or rotational symmetry of 2. This figure, if you're looking at this one, again, I'm thinking about in a circle, so my center point's there about the center. I could rotate this figure once, twice, 3 times, and it looks exactly the same, and so this has a rotational symmetry order of 3. So along those lines, if you're looking at this figure here and you're thinking circle, and pause the video, see how many times you think it would rotate. Start it when you're ready. Okay, so you should have said that rotational symmetry order of 4 because it looks the same in all 4 positions. So let's practice a little bit with a little bit harder ones. Well, these aren't harder yet, but here's one. So think about what the order is. Pause if you don't want to see the answer right away. So you should have gotten 4. Okay, this figure, pause if you don't want the answer right away. You should have gotten 6 because this can be rotated 6 times within the 360 degrees. And this figure is pretty easy. I'm not even going to pause the video on that. Hopefully you know that that one's a 3. And the H, we talked about that in the beginning. So taking this H in a 360 degree, you could see that it had an order of 2. Let's look at some that aren't so easy to figure out. Oh, like this figure here. So think about what the video is, or what this rotational symmetry would be. Pause if you need to. All right, so if you said 12, oh, you would be off. Because if you would take this black and go once, this is no longer black, that's white, so it doesn't look exactly the same. So I would have to go all the way to this point here to make it 1 rotation, 2 rotation, 3, 4, 5, and then back to 6. So this actually has a rotational symmetry of 6. What about this figure? Pause the video. Okay, this one has 3. Taking this black area right here, where is it black again? Right here, looks the same. Right here, and then back to the top. And then along those lines, what about this figure? This one really has none because there's no way I can rotate that to make it look exactly the same. Now for our purposes, I'm going to say it has a rotational symmetry order of 1. So 1 and none think the same thing. So you're not actually going to draw these. If you were in my face-to-face class, you would. But you're going to look at these 6 figures and you're going to try to figure out if they had a rotational symmetry order of 2. In other words, they were turned 180 degrees about the center point, the blue dot, what would it look like? So pause and see if you can get a visualization, and then when you start it again, you'll see it appear. Notice on number 2, the original, I call it the flag, the little extra tag here is facing down, but if you rotate it 300 or 180 degrees, it's facing up. So along that lines, did you think 3 for that? Looks like that. What about 4? And notice that this is really weird because of that rotational point. And 5 would look like this. And then 6 because of that rotational point. So I'm getting you visuals trying to think about what rotational symmetry looks like. So these next shapes we're going to talk about, and I'm just going to go through them, and I'm going to show you what it would be if it had an order of 4. Now the original shape for 1 is that. I kind of like got trigger happy here. So there's 1, 2, 3, and then back to the original, so that has 4. Shape number 2, 1, 2, 3, and then back to the original 4. Same thing with 3. That one's a cool looking one. Now my geometry spatial people, you're loving this lesson. The rest of us, if you're like me, you're struggling, but that's okay. So 4, this dot makes a difference, so let's look at it. There, it's like almost on top of each other, so that's what the 4 would look like. And number 5, okay, and then number 6 is really cool looking as well. Okay, so rotational symmetry, think circle 360 degrees. All right, so the next part of this lesson is talking about line symmetry. Line symmetry is if you would cut the object in half, it would look exactly the same. It would mirror itself. So if I were talking about number 1, could I put a line and see, and it be folded over on each other and look exactly the same? And if so, how many lines would work? So if you want to guess, pause the video. Otherwise, here we go. So number 1, I could do a line there. If I fold it over, it looks the same. 2 lines, 3 lines. All those would look the same. So this figure has 3 lines of symmetry. Okay, number 2. You have this way, if you fold in half, looks the same, and then long ways horizontally. So this object has 2 lines of symmetry. And what do you think for 3? Did you see that? That only has 1, as well as number 4. So the second part, or B part, says, for what shapes have a rotational symmetry? Then write down its order. So I'm asking you, could this be turned in any amount in the 360 degrees and look exactly the same? Could this one? And then so on and so forth with the 3 and the 4. So take a minute and think about it. So you should have said that 1 has rotational symmetry. I put that red line there if you're watching the video. So it goes 1, 2, 3 places. So that has a rotational order of 3. The second figure, and if you watch that, there's 1, 2. So that has an order of 2. And then 3, you could only go 1 time. Order of 1. Again, remember I said 1 and none, but I like to use the order of 1. And then number 4 is the same as an order of 1. So that is line symmetry. So for the following shapes, look at the shapes labeled A through F. Write the letter of the shapes that have 2 lines of symmetry. So only 2 lines, no more. So take a look and start the video when you have them. I'm going to give you part 2 in just a second. All right, so part 2 says write the letter of the shapes that have a rotational symmetry order of 2. So only 2. All right, so after you get your answers, start the video again. All right, so back to number 1. What shapes have 2 lines of symmetry? The only shapes that have 2 lines of symmetry are A and F. Number 2, which ones have rotational symmetry? Well, we've got A, B, and F. So this would be 1, 2. This would be 1, 2, and this would be 1, 2. So they all have the order of 2. Okay, so looking at these road signs, let's write down the letter of the 2 signs that have only 1 line symmetry. So can you find it? Pause the video. Okay, you have your answer. So now write down the letter of the sign that has rotational symmetry and state the order. So there's only 1 sign that has rotational symmetry. Okay, so the answer to number 1, the 2 signs that have line symmetry are B and D. Cannot fold this in half because the arrows do not match up. Has to look exactly the same. And then the second part of this is if you're finding the rotational symmetry, only C does, once, twice, and 3. So the rotational order of 3. So for the magnitude, that is something I need to talk to you about. Magnitude, I'm going to give you another short video on, and it's very easy as well. Once you know rotational symmetry, magnitude is super duper easy. And I'm trying to escape and stop the video. Technology is fun, is it not? All right. Talk to you guys in a minute.